In this video, we're going to continue our work with curve sketching and look at some further examples. In the first question, we're asked to sketch and label each pair of graphs on the same set of axes, showing the coordinates of any points where the graphs intersect. We're asked to write down the equations of any asymptotes. Generally speaking, you'll be expected to be able to draw linear graphs, so y is equal to mx plus c, quadratic graphs, cubic graphs and reciprocal graphs. I've included some of these for completeness. So let's look at a couple of examples. Let's go for y is equal to x squared and y is equal to x to the fourth. X squared is just a standard parabola, so we have now the parabola symmetric about the y-axis and we have the minimum point or the vertex at the origin, and that will look something like so. Remember, this is just a sketch. It doesn't have to be massively accurate. So we've got this point right here, which is 0, 0. Let's now consider x to the fourth. Now if I take a value, let's say we got 1/2 and we square 1/2, we'll end up with 1/4. If I take 1/2 to the power of 4, this is going to give me 1/16. For all values between -1 and +1, we're going to have now the quartic graph, x to the fourth, below now the quadratic graph. For values above 1 and below -1, if we consider, let's take 2. If we take 2 to the second power, that's going to give me 4. If I take 2 to the fourth power, that's going to give me 16. So for large values of x, whether that's positive or negative, we're going to get a larger value of y when we take the graph or take the value to the fourth power. So let's have a look at what we've got. Clearly, we're going to have a point of intersection just here and just here. And that's going to be now -1, so -1, 1 and 1, 1. What we'll have now is the quartic graph, and it'll look something like so. So we'll be below the quadratic, we will meet at 0, 0, we'll come back round, and it'll do something like that. So we can see this flatter part here, and it will be below the quadratic. So let's go ahead and label this. Y is equal to x to the power of 4, and then we have now y is equal to x to the power of 2, or x squared. So let's say we didn't recognise now these points of intersection. Let's go ahead and solve a simultaneous equation. If y is equal to x squared and y is equal to x to the fourth, we can therefore say that x to the fourth will be equal to x squared. Subtracting x squared from both sides, x to the fourth minus x squared is equal to 0. We can factor this. We've got x squared as a common factor. X squared minus 1 is equal to 0. So either x is equal to 0 or x squared minus 1 is equal to 0, which would mean x is equal to plus or minus 1. So we can see this point -1, we've got 1 and we've got 0. So we're just looking now to use a bit of intuition. In terms of you being expected to recognise that graph, it could be argued that you wouldn't be expected to recognise it, but you can now deduce its general shape and some points on there and what it's going to look like by thinking about some obvious values. Now both of these are what we would say are even powers. When we have a negative value and an even power, our answer is going to be positive. And this is something that we looked at on the rules of indices. Okay, let's look at another one. Let's go for this one. Y is equal to 1 over x and y is equal to 1 over x squared. So what I'll do is y is equal to 1 over x. We've met this graph in a previous video. This is the reciprocal graph. So we'll come down and it will never end up being 0, but now we will tend to 0. So as x gets very big, y is going to get very small. We had the asymptotes to be the x and the y-axis, or if you like, y is equal to 0 and x is equal to 0. So first thing I'm going to do is scribble these down before I forget them. So we can say now that the asymptotes are going to be now x is equal to 0 and y is equal to 0. And I've drawn a quick sketch. Let's consider now x to the second power, 1 over x squared. What we're going to end up having is something that looks like so. So if I now took this point right here, this point is going to be 1, 1. So on the graph we got 1, 1. So if 1 goes in here, we're going to get 1 back. If 1 goes in here, we're going to get 1 back. Now let's say let's say this is the f of x. So let's say that's the f of x, and I did now the f of 1/2. The f of 1/2 is going to give me now 1, so if I put this in, it's going to give me 1 over 1/4. Now 1 over 1/4 is going to give me 4. So what we're going to end up doing now is coming to the right of this particular point here. So we're going to come here, and then we will come through like so, and then it will now come round and round like that. So we'll never, this will never actually be 0, but it will tend to 0. So if we think about values here, let's take this point right here. Let's now think about the f of 2. So if I think about the f of 2, and I say that this is now the f of x, that's going to give me 1 over 4. Yet if I did the f of 2 in this particular one, I get 1 over half. So we can see at this point right here, the white line will be above the red one. With this one as well, anything to the left, we're going to end up now with a positive value. So let's come up here like so. So what we've got then, if we consider, if I did now the f in this one particular one, let's do the f of minus 1. Well, we're going to square that, so it's just going to give us 1 over 1, which is 1. If I did now the f of minus 2, well, it's going to give me now 1 over 4. So we end up now with y is equal to 1 over x squared, which is the red graph, and then the white one is y is equal to 1 over x. Now, we can say that this is not defined, either graph is not defined for 0, and we spoke about that in the last video. So we've got now y is equal to 1 over x, where x cannot be equal to 0, and then we've got y is equal to 1 over x squared, where x cannot be equal to 0. We can't divide by 0, it's undefined. So let's just show now algebraically that there's one point of intersection here. So what we've got here then is y is equal to 1 over x, y is equal to 1 over x squared. Therefore we can say now that 1 over x squared will be equal to 1 over x. Therefore we can say that x squared will be equal to x. Subtracting x from both sides, x squared minus x is equal to 0. And factoring, we've got x minus 1 is equal to 0. So either x is equal to 0, and we know it can't equal 0. Therefore, now we've got x is equal to 1. And we could go ahead and sub that in now and show that the y coordinate is 1. So nice and logical, nice and straightforward. Okay, let's do one more. Let's look at this one. Y is equal to x, and y is equal to the square root of x. When we talk about the square root of x, we talk about the positive square root of x. Now, this is going to look something like so. We're going to have now the following. We'll come up, round, and it'll look, give or take, like so. So this now is y is equal to the positive root of x. What I'm now going to draw is the line y is equal to x. This is a straight line through the origin, but it'll look something like that. Gradient of 1, we've got now the y-intercept of 0, 0. So we can see that there's going to be 2 points of intersection. We've got one just here and one just here. So let's go ahead and write this on. Now, we could probably tell what that number is going to be, but let's just show this is going to be the case. So if y is equal to x and y is equal to the square root of x, therefore we can say that x will be equal to root x. I'm going to square both sides. X squared is equal to x. Subtracting now x from both sides. X squared minus x is 0. X minus 1 is equal to 0. So we can see now that this point right here, we've got either x is equal to 0, which corresponds to the origin, and then we've got the other one, x would be equal to 1. So we've got this point just here, so that's going to be 1, 1, and then we've got 0, 0. So nice and straightforward, nice and logical, and we end up now with y is equal to x and y is equal to the root of x. So on this particular one, we don't need any asymptotes either. The only one that we needed the asymptotes on was the reciprocal graph. Okay, let's look at some more examples. We're given in this one the f of x is equal to x minus 1 multiplied by x minus 3 multiplied by x minus 4. So straight away I'm looking at this and thinking this is going to be a cubic equation. We can see it's going to be positive. X times by x is x squared times by x is x cubed. So there's no negative in there. What we need to do is find the f of 0. Now if we do the f of 0, what this is telling me is simply to put now 0 in for x. So what we're going to have then is minus 1 we're going to have minus 3, and we're going to have minus 4. So we can say the f of 0, we're evaluating the function now when x is 0. That's going to give me 12 and then minus 1, so we're going to get minus 12. The f of 0 now tells us the y-intercept of this particular graph. We're now asked to write down the solutions of the equation f of x is equal to 0. So what we're saying now is if we set this to 0, what are the solutions? And write down means that we should just spot this. These are all linear factors. So if we have now 0 is equal to x minus 1 multiplied by x minus 3 multiplied by x minus 4, we can say that either x minus 1 is equal to 0, x minus 3 is equal to 0, or x minus 4 is equal to 0. So it's either x is equal to 1, x is equal to 3, or x is equal to 4. We now need to sketch this, and in the previous video, or the one before it, we looked at sketching positive cubic equations. So we've got the roots of our equation. They are going to be at 1, they're going to be at 3, and they're going to be at 4. These don't need to be massively accurate. We've got 1, we've got 3, and we've got 4. We know that the y-intercept is down here, and again this is not hugely accurate, we just asked for a sketch, and that's 0, minus 12. When we have a positive cubic equation, we come from the third quadrant and then we go out through the first. So what I'm going to do is just draw a quick sketch. So we're going to come up through this point right here, we will turn round to a maximum, we will come through, we will turn round to a minimum and back through, and we can just now draw a sketch. So we can say now y is equal to the f of x, or we can say y is equal to x minus 1, x minus 3, and then x minus 4. And we have the main pieces of information that we need. So a positive cubic equation, and we've got these three distinct roots. So 1, 3, and 4. Okay, we're asked to sketch each graph showing the coordinates of any points of intersection with the coordinate axis. If we look at all of these are going to be cubic graphs. So let's have a look and we'll go through them and then graph some of them. So this is going to be now a positive cubic equation. We can see the roots or solutions, x will be equal to minus 1 or 3. So all we're doing is looking at these linear factors. If I look now where this is going to cross the y-axis, that's when x is 0. It will be 1 times by minus 1 times by minus 3. So we can see that this will go through the point 0, 3. So if I wanted to do that one, that would be nice and straightforward. Let's look at this one right here. Again, this is going to be a positive cubic equation. We're going to have a term in x cubed. We're going to have the solutions now at x is equal to 0. Just consider this is where y is 0. So 0, 1 or 5. So 0, 1 or 5. If we think now where this is going to cross the y-axis, well that's when x is 0. So we'll have now the origin. So let's go ahead and draw that one. Let's put that one on and we can place that on. So what we're going to have is a positive cubic. We're going to have the points of intersection. We're going to have three distinct real roots. We're going to have 0, 0. We're going to have now 1, 0, and we're going to have 5, 0. This will go through the origin and it will look something like this. We turn round to a maximum, we come round to a minimum, and then we go back through this point right here and we can label this up. Y is equal to 2x multiplied by x minus 1 multiplied by x minus 5. And we've got all of the information we require for that one. Okay, let's look at the next one. This one right here, it looks like we've got x, 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 so that gives me a positive term, and then we have the negative out front. So we can see that this is going to be a negative cubic equation. We're going to have now the roots. X will be equal to minus 2, we've got minus 1, and then we've got positive 2. If we look now, this is going to go through, and we need to be careful with this, if we look at this now. If we subbed in 0 just here, that's 2 times by 1, which is going to give me 2, times by minus 2, which is going to give me minus 4, times by minus 1, so that's going to give me now 0, 4. So let's go ahead and do that. We're going to have 0, positive 4. So let's draw a quick sketch. With our negative cubic, we're going to come through and in the second quadrant and out the fourth. So let's go ahead and locate these roots. We've got now -2, -1, and then we've got +2. So what we've got then is the following. We'll have something that looks like this. We'll come round, and then we'll come back up, and we're going to come through now the y-axis just here, and we'll come back round through like so. So it looks something like that. That is going to be 0, 4. This is going to be -2, 0, -1, 0, and then we're going to have 2, 0. So we've got 3 distinct now linear or distinct real roots to that equation. Okay, let's look at the next one. Now with this one, again, this is a cubic equation, and we've looked at these types before. We have a repeated root. We've got an x squared term, so we can say this is positive, and we've got x will be equal to 0, 0, and 4. I'm just emphasising now that we're going to have this repeated root. That means it simply touches. We can see that this will go through the origin when x is going to be equal now to 0. So we're going to have a positive, and let's go ahead and draw this. We're going to have a positive, and when I say it will go through, it will touch. It will touch the origin. We're going to have now a positive cubic equation. So let's do that. So we come up through the third quadrant. We now turn at the origin. So it touches the origin. That is the repeated root. And then we'll come through and we'll come back up like so. So we've got now this point, which is going to be 4, 0, the repeated root just here. And we can say now that is y is equal to x squared multiplied by x minus 4. And of course we can just label that up. That's the general practice, x squared, x minus 4. And it touches the origin. Okay, this one, the repeated root, would be now at 1. So let's just finish the last couple off and then we'll move on. So let's look at this one right here. So what have we got? We've got x is 0, x is minus 2, or x is equal to 1. So this is going to be a negative. I've got x times x, which is x squared, then minus x, which is minus x cubed. So I'm going to have 1 just here at 0, 0. I'm going to have 1 here at negative 2, 0, and I'm going to have 1 here at 1, 0. If we consider this is going through the origin when x is equal to 0 on here, we'll go through the origin. So what we want this time is the following. We'll come round like so, back through the origin to a maximum point, round, and then we'll come out the fourth quadrant. So we come in now through the second and out through the fourth. Y is equal to 3x, 2 plus x, and then finally now 1 minus x. And we've labelled that up. Okay, let's finish off with this one right here. So what we've got here now is x plus 2 and then x minus 1 all squared. So we've got now a repeated root. That repeated root is just here. Then we've got now this one, which is minus 2, 0. If we consider now, and we need to be careful with this, we're going to have, when x is equal to 0, we're going to have 2 times by positive 1 as we're going to square this. So we end up now with the following. This point is going to be 0, 2. So we come round and we'll end up now, let's just do this, let's come through, and this will give us our values. So let's just draw the sketch, let's go through. So what we want to do is do this, come round, let's go round through that point here, and then it will just touch now and then go back up like so. So that'll be a nice rounded point and just touch, and we can say that y is equal to x plus 2, let's get all this in, x minus 1 all squared. So that's what we end up with. We've got a positive cubic equation, we come through, in through the third, out through the first. Okay, let's move on and look at another one. What else have we got? Okay, we're asked to factorise fully x cubed plus 6x squared plus 9x. So let's do that. Common fact here of x. So we can say x, that's going to leave me x squared plus 6x plus 9. We can factor this further. We've got now x plus 3, x plus 3. So this is giving me a perfect square. So that's fully factored. In part B it says, hence sketch the curve y is equal to x cubed plus 6x squared plus 9x, showing the coordinates of any points where the curve meets the coordinate axis. Okay, so let's go ahead and do that. So what we need to consider is when x is equal to 0, when x is equal to 0 it will go through the y-axis, and when y is equal to 0 it will go through the x-axis. So this is what we got. It says, hence sketch the curve of y is equal to this right here, showing any points now, and we will go ahead and do that. So let's do that now, and we can do that. So what we're going to have then is this point right here. That's going to be 0, 0. We're going to have now a repeated root, and this is going to be minus 3, 0. So we'll come up, we'll turn round after we've touched it, come round, and then back through the origin like so. So that's what we've got, and that now gives us exactly what we're looking for. So that's the curve sketched. By factoring, we've got these points. And in part C, it's asking me to do exactly the same. Sketch a curve. I'm assuming this is the f of x, but we'd have exactly the same. So let's just call this the f of x, and we'll say that the f of x is x cubed plus 6x squared plus 9x. Okay, let's move on. Given that the constants p and q are such that p is greater than q, which in turn is greater than 0, sketch each of the following graphs showing the coordinates of any points of intersection with the coordinate axis. So let's see what we've got here. Now this is x minus p, x minus q all squared. So what we're going to have now is the following. We're told that p is bigger than q and q is bigger than 0. So we're told essentially these are positive values. So what we're going to have then is the following. We're going to have the first one. Q is the smaller of the two, and this is going to give us now a repeated root. Then we're going to have p just here. So this is going to be p, 0. So all we need to show are the points of intersection. We need to be very careful now because we want to show the points of intersection with the y-axis. So what we're going to have is when x is equal to 0, I'm going to have minus p multiplied by q squared. This is greater than 0. This will always be greater than 0. Therefore, this is going to give me now a negative number. So what we're going to have then is this point down here, and this will be 0, minus pq squared. Now, the repeated root is here at q. So what we're going to have then is the following. We're going to come up through the third quadrant, we will touch, and then it will turn round, and we'll come back through. We'll have now the minimum point, and then it will come like so, and it will go out that way. So that's what we end up having. So we've got now this cubic function. We've got now a root at p. We've got a repeated root at q. P is bigger than q, which in turn they're both bigger than 0. Therefore, they're positive numbers. So when x is equal to 0, we can go ahead and put on 0, p minus p squared, minus pq squared. Right, let's look at this one. The first thing I'm going to do is have x minus p, and then spot that this is the difference of squares. X plus q, and then we're going to have x minus q. So let's see what we're going to end up with then. If we consider now, let's do this. We've got now the points, and we're told that p is going to be bigger than q. So we can see that we're going to have positive p and positive q. So exactly the same as we had before. We've got now q just here. We've got p just here. We've also got minus q. So we have to show that that's generally equidistant from the origin. So what we'll have then is minus q. So we've got minus q0, we've got q0, and we've got p0. Let's now consider when x is equal to 0. This is going to give us now minus p multiplied by minus q squared, which is going to give us pq squared. So what we're going to have then is this point right here at 0, pq squared. Now this is still going to be a positive cubic equation. So what we're going to do is come up through the third quadrant, we will turn around like so, we'll come through, it'll come round like that, and then we'll come back up, and it will go through like so. So, Given that the constants p and q are such that p is greater than q, which is greater than 0, sketch each of the following graphs showing the coordinates of any points of intersection with the coordinate axis. So quite a nice little question here, as we're dealing with constants rather than these numeric values. Okay, let's move on and look at something else. On pi, we're asked to sketch on the same set of axes the graphs of y is equal to x squared and y is equal to 1 minus 2x. So what we've got here is a quadratic, a parabola, and we've got the origin, and then we've got a straight line graph. You might want to rewrite the straight line graph in the form y is equal to mx plus c, or you might just leave it as it is. So here's our quadratic parabola, and it'll look something like so. So y is equal to x squared. Now the other one, if you wanted to rewrite it, y is equal to minus 2x plus 1. So what we're going to have here is a straight line equation, and let's do that. So we're going to come through and it will look, give or take, like so. So let's put a gradient on here, and we'll put this on. Let's do that. We'll put a gradient now, and that looks pretty good. So what we've got then, let's put the point here. So we're going to have this point right here. This is going to be 0, 1. So when x is 0, y is going to be equal to 1. We've got the origin just here where this is touching. Now if we consider this point right here, that is when y is equal to 0. So we've got minus 2x plus 1. So we can say 2x is going to be equal to 1 and x will be equal to 1/2. So this point right here is going to be 1/2, 0. And we can say that this is y is equal to 1 minus 2x. It says in part B, hence state the number of roots that the equation x squared plus 2x minus 1 equals 0 has, and give a reason for your answer. Now let's look at this right here. This line intersects a curve here and here. If y is equal to x squared and y is equal to 1 minus 2x, therefore we can say that x squared is equal to 1 minus 2x. We can say that x squared plus now 2x minus 1 is equal to 0, rearranging. So at this stage we can show now that rearranging the graph gives us 2. If you wanted to double back that, and it says hence state the number, we've got 2 roots, and give a reason for your answer. Well, this provides us with a solution to this particular equation right here, and we can show that graphically. So some reference to setting these two graphs equal and showing that they have 2 points of intersection. So we can say now 2 points, so 2 points of intersection. What you could do as well is show now the discriminant on here. So we've got a value of a is equal to 1, a value of b which is equal to 2, and a value of c is equal to minus 1. So b squared minus 4ac. If we consider now, we're going to get b squared. Well, that's going to be 4. And then we're going to get minus, and let's put this in, we're going to have now minus 4 times by a, which is 1, times by c, which is going to give us 0. So we end up with 4 plus 4, which is 8. Therefore, we can say 2, let's write this here, 2 distinct real roots as b squared minus 4ac is going to be greater than 0. Generally speaking, where you make some reference to the intersection of these two graphs. Okay, let's go on and look at another one. It says find the coordinates of the turning point of the curve y is equal to x squared plus 2x minus 3. Okay, now turning points can either mean that you differentiate or complete the square. If it's a quadratic, often you complete the square. So the turning point in this particular case is going to be the minimum. So what I'm going to do is complete the square. So just writing it here, complete square for turning point. As stated, when you come on for to differentiation, you can do it another way. So we take x plus half the coefficient. So we'll have x plus 1 all squared. We subtract away the 1, we subtract away the 3. So what we'll have then is x plus 1 all squared minus 4. If we look at the transformation of the graph y is equal to x squared to this particular form, what we're going to have is a translation of minus 1 minus 4. So let's go ahead and do that, and I'll draw a quick sketch. So what happens then is the following. We're going to have now something that looks, give or take, like so. So we're going to have now minus 1 minus 4. Let's put this just here. That's going to be minus 1 comma minus 4. Okay, now if we look at this, we could say to ourselves, does it factor? Let's see if we can go ahead and factor. So we need two numbers. So if we think about this now, we could have x plus 3 and then x minus 1. So we could see that we'd have this one right here. Let's put that just there, and then we'd put this one just here. So if we wanted to sketch this up, let's just go ahead and do that. That's what we'd end up with. So find the coordinates of the turning point. Well, that's going to be now minus 1 minus 4. In part B, it says, by sketching two suitable graphs on the same set of axes, show that the equation x squared plus 2x minus 3 minus 1 over x equals 0 has one positive and two negative real roots. So let's go ahead and do that. So what we'll do, we'll now sketch the parabola. Okay, what I'm going to do here is the following. I'm going to draw two different graphs. This point is going to be minus 3 comma 0. This point is going to be 1 comma 0. This is the graph of y is equal to x squared plus 2x minus 3. Let's consider this right here. Let's rewrite this. X squared plus 2x minus 3. And I'm going to add 1 over x to both sides. So what we're going to have are two graphs. So let's just write this here. So we're going to have two graphs to solve this. We're going to have y is equal to x squared plus 2x minus 3. And we're going to have y is equal to 1 over x. So if I think about now 1 over x, let's do a different colour. What we can do is the following. 1 over x is our reciprocal graph. So we've seen this in action like so. So that is our positive root, and we can see that we're going to have two real roots in the negative area. That's not massively accurate, but it gives us some idea. So there's our positive one, and we can say y is equal to 1 over x. And we've done this purely graphically by sketching two suitable graphs. Well, there's our two suitable graphs. Y is equal to x squared plus 2x minus 3, and y is equal to 1 over x. Let's look at one last example. In this one, we're asked to solve for simultaneous equations. Y is equal to 3x plus 7 and y is equal to x squared plus 5x plus 8. What we can say, therefore, if y is equal to the quantity here and the quantity here, we can set these equal. So we can say 3x plus 7 will be equal to x squared plus 5x plus 8. So, setting the left-hand side to 0, we're going to have x squared plus 2x plus 1. This will factor. This is going to give me now a perfect square. That's x plus 1 multiplied by x plus 1, or x plus 1 all squared. So this gives me now that x will be equal now, if x plus 1 is equal to 0, then x will be equal to minus 1. And then all we do is sub it in for y, so we can say y is going to be equal to 3 lots of minus 1 plus 7, so we have y is equal to 4. So we've got now x is minus 1, and y is going to be equal to positive 4. In part B, it says, hence describe the geometrical relationship between the straight line y is equal to 3x plus 7 and the curve y is equal to x squared plus 5x plus 8. What we can see here now is that this is going to be a repeated root. If we consider the discriminant here, and we certainly don't have to, we can just see there's one point where this is going to touch. If we look at this point right here, we've got a is equal to 1, b is going to be equal to 2, and c is going to be equal to 1. b squared minus 4ac will be equal to 0 if now a tangent. So if this line is a tangent, what we're going to have is b squared minus 4ac is going to be equal to 0, as there's going to be one repeated root. And we've seen this anyway, but you can just show this. You can say, now b squared, which is going to be 4, minus 4 lots of 1 times by 1 is 0. So we've got now this quadratic, we've got now x squared plus 5x plus 8, and then we've got the line 3x plus 7. Now, of course, we could just state now that this is a tangent and just show that. What I'm going to do is just go ahead now and look at these two particular graphs and have some idea of what we're going to have. So what we're going to have then is the following. Let's complete the square on the quadratic. So we've got x plus 5 over 2 all squared. minus this number squared, which will be minus 25 over 4. Then we're going to have now plus 8. So I'm going to write that as plus 32 over 4. So in completed square form, we've got x plus 5 over 2 all squared, and then we're going to have, what's that going to be, plus 7 over 4. So if we looked at this quadratic now, we can see there are going to be no real roots to that. So let's go ahead and draw a quick sketch. So what we're going to have then is the minimum point, it's a positive quadratic. We're going to have now minus 5 over 2 and then 7 over 4. Let's put it just here. So minus 5 over 2, comma, and then we're going to have 7 over 4. And that's going to be opening now upwards. So it's going to look something like so. Now, what we've got is the following. We're going to have now a tangent to this, and that's going to happen when x is equal to minus 1. So this is our curve, and let's do that. Let's put it like so. That's what it's going to look like, give or take. So what we've got then is our line and our curve, and we've got this one point of intersection, and that point of intersection is now going to be at minus 1, comma, positive 4. So this is the line. Now y is equal to 3x plus 7. So let's put this on. Y is equal to 3x plus 7. The point of intersection here is going to be 0, 7, and we can see now that it becomes a tangent. There's one now repeated root. So we weren't asked to do that, it was just a nice way to look at it and state now that it would be a tangent. So for that particular question, you certainly don't need the discriminant and you don't need the sketch, you just have to make some reference at this stage right here to be a repeated, so let's write this in, repeated root, therefore now a tangent. I just like to think of different ways that you could show this and back up your theory. So there we go, a bit more work involving curve sketching, and in the next video we'll move on to some more graph transformations.